Good evening class. In this video we are just going to see that what is triangle of vector addition. Okay, so as it is clear from its name, it is somewhat triangle. Okay, so a particular law related to vector addition which confined in the triangle, so that is called triangle of vector addition. Graphically we have to just see that what is it. Okay, let's suppose if two vectors are representing two sides of any triangle in magnitude as well as in direction. If any two sides are representing by the help of the vector, so their closing side will be the resultant the closing side of that triangle will be represented by the resultant vector R. So this is our basic law. I am just going to describe it again, that if any two sides of the triangles are represented in the magnitude and the direction by the help of the vectors, so the closing or the third side of that particular triangle will be represented by the resultant of these two vectors. So this is our basic things related to it. So just see here, in the triangle law of addition, two sides may be of any side. Let's suppose this is a A and this is B. So whatever the third side, so that will be the resultant. And we better know that in the resultant side, head will be towards the head and tail will be towards the tail. So this is some basic things related to the triangle's law of vector addition. Okay, now this is the basic thing, but we have to just explain it in the magnitude term as well as in the direction term. Okay, so for that purpose we have to just derive it. Okay, so the derivation of triangle law of vector addition, just see. Okay, let's suppose the resultant of these two vector A and B is making an angle alpha with this vector A. Okay, and I am just producing this particular vector A, this side in the forward direction. Okay, so this is the forward direction in which I am just representing, and this can be treated as a line of action of force. What? Line of action of force. And from this end, let's suppose this is the point A, this is the point B, and this is your point C. From point B, I am just going to draw a perpendicular line on this produced line. Okay, so this is our perpendicular line, and where it is just meeting to this produced line, so that can be treated as D point. Okay, okay, always we have to just take a smallest angle from tail to tail addition. So let's suppose if this vector is produced in the forward direction, so it can be just represented by like this, and this is the point of joining between the vector A and B. Okay, so from this point, from tail to tail combination, a point where the two vectors tails are met, we have to take an angle. So let's suppose this angle is what? We can just take it as a theta. This is very important. Always we have to take an angle from tail to tail joining, not from the head to tail, tail to tail. This is very important. Whether it is of any law, if we are just considering the angle, so that angle will be from tail to tail joining. Okay, so now we can just project this particular side in the horizontal as well as in the vertical direction. Just see here, I am just considering this triangle BCD. Okay, let's suppose this is our BCD, right angle triangle, and CB is representing the vector B. So we can just project this vector in the horizontal as well as in the vertical direction, and if this angle is theta. So what will this horizontal component? So that can be treated from the cos theta. If I am just taking a cos theta for this triangle, so the cos theta will be what? CD by BC. And if I am just taking a cos theta, just see here, if I am taking a cos theta, okay. So if you are taking a cos theta, so cos theta will be what? It will be CD by CB. And CB represents the vector B, so we can get the CD also. So CD will be what? It will be B cos theta. Okay, so like that we can just calculate the BD also. If in this triangle I am just taking a sin theta, so from there we will get the value of BD, so that will be what? B sin theta. So now we can get the value of CD as well as BD, means the portion of vector B in the horizontal direction as well as in the vertical direction. So for in the horizontal direction, the component B cos theta is applicable, and the vertical direction the component is what? B sin theta. Okay, so from the projection we can get the result of this particular vector B in the horizontal as well as in the vertical direction. Okay, now just see the right angle triangle ABD. What? Right angle triangle ABD. So in this ABD triangle, we can just apply the Pythagoras theorem. That is what? That is the square of the hypotenuse is equals to the sum of the square of the perpendicular as well as base. So we can just write from the Pythagoras theorem that what? AB square is equals to AD square plus BD square. This we know, and we can just put here also. So in a place of AB we can just put the respective vectors. So in a place of AB we can just write R. So here R square is equals to, in a place of AD, just see here, AC is represented by A and CD is represented by B cos theta. Both are in the same direction, that's why will be added. So AD represents what? A plus B cos theta. Okay, means AD we can write na AC plus CD. So AC is represented by A and CD is represented by B cos theta. So whole term will be represented by A plus B cos theta. So in a place of AD we have to put what? A plus B cos theta of whole square, and a place of BD we can just substitute B sin theta. Okay, now you have to just solve it. Here we can just put the identity A plus B of whole square. So that is A square plus B square cos square theta plus B square sin square theta. Okay, now we can just take common B square from these two terms, then we will get R square is equals to A square plus, we can take common B square, in bracket you will get cos square theta plus sin square theta, and that is identity, that is equals to what? This is equals to 1. Okay, and here one more term is missing, that A square plus B square plus 2AB cos theta. Okay, so by mistake I have done this. You see here, B square cos square theta plus 2AB cos theta and plus B square sin square theta. Now we have to take common B square from this term, and then we will get R square is equals to A square plus B square. If you are going to take common, then you will get cos square theta plus sin square theta and plus 2AB cos theta. Now this is equals to 1. So R square is equals to A square plus B square plus 2ab cos theta. This is our desired result. And if I am just going to take a value of r, so we have to take under root also both the term, then r is equals to under root of a square plus b square plus 2ab cos theta. This is a desired result. You need to know this is the relation in the magnitude of the resultant as well as between the vector. This relation does not include any directional term. This is very important need to know. Here I am not using any vector sign, it is having only the magnitude. So that is the relation between the resultant and two vector. This formula is applicable whenever there is a two vectors are making an angle theta and resultant is r. So what is the relation between their magnitude? So simply we have to use this one. R is equals to under root a square plus b square plus 2ab cos theta, where theta is the angle between the vector joining from tail to tail. It is the least angle between tail to tail, and r, a, b are the magnitude of the vector. Now let's suppose if I'm trying to find the direction of the resultant, okay, direction. So that term was, let's suppose the resultant vector is making an angle alpha with vector a, okay. So in this right angle triangle ABD, if I am considering a right angle triangle ABD and I am just taking a tan alpha, what I am taking? Tan alpha. So tan alpha is equals to what? It is just this side BD upon AD. So tan alpha is equals to what? It is just perpendicular upon base BD by AD. Okay, in a place of BD we can put B sin theta, and a place of AD from here A to C is what? Vector A, and C to D is what? B cos theta. So it will be what? A plus B cos theta. Okay. By the help of which we can just find the resultant direction from any of the vector. Let's suppose this is alpha, it means resultant is making an angle alpha with this vector A. So by which we can just find the direction also. From here you can find the value of alpha, that is equals to tan inverse B sin theta upon A plus B cos theta. Okay. This is the angle from vector A. If let's suppose if I am just trying to the angle between the resultant and this vector B. So what will be? Changement will be there. A and B will be interchange. This is very important. If this alpha I am just taking here, let's suppose if in this triangle I am taking alpha here in a place of it, okay, it means this is the angle from a resultant to this particular vector B. So there will be some changement, A and B will be interchanged, you need to know. Okay. Some basic examples also you have to just see. Let's suppose vector A having a 5 Newton magnitude and vector B having a also 5 Newton, and their tail to tail angle is 60 degree. Okay. So are they saying that find the direction of the resultant? What? Find the direction of the a resultant, or they can ask you find the magnitude of the resultant. So how we can get the resultant magnitude? That is R is equals to what? We know the formula, under root A square plus B square plus 2AB cos theta. By the help of this formula we can get the resultant magnitude. Here we have to put in a place of A 5 Newton, in a place of B this 5 Newton, and in a place of cos theta we have to put theta is equals to what? 60 degree, and we can get the result of R. Now let's suppose for the direction, what formula we can use? Tan alpha is equals to B sin theta upon A plus B cos theta. By the help of this formula we can get the direction of the resultant with the vector A. Okay, with the vector A, that in which direction the resultant will be there. Okay class, so this was our triangle law of vector addition. In the next video I am just going to explain the parallelogram law of vector addition, and then we will just solve some complicated numericals based on these two formula. Thank you.